So this problem reads, 500 people are asked about whether or not they have piercings. The following chart shows the results. Then it says, what is the probability that the person asked is a man, given that they are pierced? And what is the probability that the person asked is pierced, given that they are a woman? So the first thing you need to notice in this problem is that both of the problems read given that, right? Here's the given that. Here is your given that, which means that this is going to be a conditional probability problem. Both pieces of it are conditional probability. So the formula reads, the probability of A given B is equal to the number of elements in A and B divided by the number of elements in B. Now, often when we see this sort of problem, we see it in terms of the probability of A and B over the probability of B. But because the chart gives us actual numbers, we don't need to deal with the probabilities. We can just deal with the numbers that we are given. So the first question reads, what is the probability that the person asked is a man? So what is the probability that a person is a man given that they are pierced? So according to our formula, this is going to be the number of the intersection of man and pierced. Man and pierced, divided by the number of people who are pierced. So let's take a look at our chart here. So if we want to find, first of all, the number of people who are pierced, we're going to go and we're going to look at our chart and we're going to look at the total number of people who are pierced. In this case, it is 324, and so that is my denominator. Now, if we want to know what the intersection is between men and pierced, what we need to do is we need to look at the column that says men. That's this column here, and the column that says pierced. So we are looking at the intersection of this row with this column, and the intersection is going to be this number right here, this 36, and so that is my numerator. So 36 is where the row and the column intersects. 324 is the total number of the boys pierced. And when I do this division, I get that the probability is 11.11%. That is the probability that a person who is asked will be a man, given that we know that they are pierced. Okay, let's look at the second question. So this problem asks us to find the probability that the person is pierced given that they are a woman, which means we already know that they are a woman. So as you can see, I have it set up. We have pierced/women, which is going to be their intersection divided by the number of women. So let's take a look first at the denominator. That's going to be the total number of women that were out of the 500 people that were asked. So if we look at female and we look at the total, that's this number here. That's the 320. So that's going to be our denominator. Now, if we want to know about the intersection, we have the intersection of pierced and women. So we're already looking at the row that says women, and now we want to look at the column that says pierced. So essentially we're saying, what is the intersection between this row of female and this row of pierced? And the answer is this right here, this 288. That's the intersection of the two rows. And so we end up with 288 people out of the 320 people. And when I do that division, I get 90%. So there is a 90% chance that if you asked a person who is a woman, they will actually be pierced. And so we're done.